Because we will use containers in this course to run our Telegram bots and our applications, we will need a primer on containers, and we will need a basic understanding of how Linux containers work. So I have prepared this section for those who have little or no experience with containers. Hopefully you will find it useful. So let's get started. First, what is a container? A container is a Linux technology that allows you to run your software and run your application in every environment, in any environment. So basically, you package your application code aligned with its required dependencies and runtimes in a single package called an image, and you then publish it to a special repository called a container repository, and then you run your application from that repository and from that image. That application that runs from that image is called a container. So regarding the nature of containers, a container is similar to a virtual machine, but it is lightweight. Why is it lightweight? Because we don't have a complete OS virtualized on top of another operating system. We only have our code and the dependencies that is different from the host. Other than that, our container will use the kernel of the host operating system on top of which it is running. So because of this, a container is lightweight. And because the containers are lightweight, they are also fast. They load faster. They don't have to boot a complete OS in order to run. They are lighter and faster. And also they are ephemeral. Ephemeral in dictionary means that something that lives only for a short time. So containers are like this. You create a container when you need it, and then you can get rid of it when you don't need it, because they are cheap, and you can have them only for a short time as long as you need them, and then you can destroy them. And of course, you can keep the information from those containers that are important for you. So being ephemeral doesn't mean that you will lose access to your important information in your application. And containers are isolated from the operating system on top of which they are running, meaning the host. So although container is using the kernel of the host operating system, it has a different file system. It has an isolated file system, and it cannot touch the files on the host OS unless we want that to happen. And there are, of course, ways for that. And sometimes this can be very useful. For example, during development, giving access to a container to write to the host file system can be very useful. You can keep the changes that you make inside the container on the host and make those changes reflect on the host file system. So now let's see how containers work. A container first uses an image. As I said, you package your application and its dependencies and runtime in a package that we call an image. This image is a read-only package, so you cannot modify it. It's immutable. You publish it, you share it in a repository, and then you and some other developers that have access to that image, they can pull that image, they can download that image, and then create containers from that image. So we create a container from an image. It can communicate with the host using ports and volumes. This can be very useful. For example, if you have a web server and you want that web server to be seen by the outside world and by the host, you need to map ports from that container to the host. And also you can bind volumes. You can create volumes for the container so that you can keep information, keep the data that you want from that container. This is enabled and this is made possible using volumes. In order to work with containers, we need special software that we call container software. Container software are software that allows us to build container images, to create containers from images, and to create volumes for containers, to delete volumes, to delete containers, stop containers, and so on and so forth. And also, these software allow us to pull and push container images from and to container repositories. Popular container software include Podman and Docker. My favorite software for managing containers is called Podman, but it's a matter of taste and it's a matter of personal preference. However, I like Podman because it has a more active open source community, and also it has more features than Docker. There's a special application called Docker Desktop that allows you to install a container software easily on your system. And this Docker Desktop also gives you a Docker CLI application, which is a command line application that you can use to manage your containers from the terminal, from the command line. Similarly, we have Podman Desktop that acts similar to Docker Desktop, but as I mentioned earlier, it has more features than Docker Desktop. And also similar to Docker, it provides us with a utility called Podman, which is a command line tool that we can use to manage our containers from the terminal. And this comes very handy for developers that love to work with command line and are more comfortable using command line interfaces. So now that we know a basic understanding of containers, how they work and what they are, let's see how we can run a container. Here's a basic example that shows you how to create a basic container. This is a basic Nginx container. As you might know, Nginx is a web server. So we run podman run, and with dash dash name, we specify the name of the container, which is app, and then we map ports from the host to the container. We map 8080 from the host to 80 inside the container. We know that 80 is the port for a web server. So when we bind 8080 from the host to 80 inside the container, this means that we can access our web server on the host by entering localhost colon 8080. And then to stop a container that is running, we can use podman stop and specify the name of the container, that here is app, and this will stop the container. And to remove a container, we can use podman rm and mention the name of the container, and this will remove the container from our operating system, from our host. There's a concept called container orchestration. When you work with a lot of containers, it's not practical to manually create and manage containers using the terminal. So we need a tool to kind of automate working with containers, to automate managing containers, to, for example, start several containers at the same time and then stop the containers at the same time, because all these containers that we are talking about can be related to one application, to one software application, to one project. So we need a way to automate bringing up those containers and then taking them down when we don't need them, without having to manually perform this in the terminal. So there are several orchestration solutions in the open source world. The most popular container orchestrator is Kubernetes, which is open source, and it is used to manage containers in production and to orchestrate containers in production. However, Kubernetes is complex and it has a steep learning curve. So, if you are looking for a simpler solution that you can use in development, for example, you need to look for an alternative. And fortunately, there's an alternative called Docker Compose, which we can use to develop our applications using containers on a host machine without having to deal with the complexity of Kubernetes. In this course, we will deal with Docker Compose because it's simpler to use and it's easier to get started with and more suitable for development. So now let's see how we manage containers with Docker Compose. Assuming that you have installed Docker Compose on your host system, you will need a compose.yaml file or a docker compose.yaml file in the root of your project. And this special file, contains the definitions of the services that are containerized for your application. And then in order to start the services of your application or your project, this file contains the definitions of images, volumes, ports, environment variables, and so on and so forth for different services of our application. So we define images, volumes, and all the other things that are required for our application once, and then after that we can simply run Docker Compose up and Docker Compose down to bring up our project or bring it down. We will not have to write commands each time to bring up our project or bring it down when developing our application. We simply use Docker Compose to automate that for us. Of course, you will see practical examples of how this is done in action. I will show you how you can do this in your project, and you will see that it is much easier than you think. So hopefully this section gave you a basic understanding of containers, how useful they are, and how we can make development or applications faster and easier using containers. And we will not have to install different dependencies on our host. We simply run our applications using containers without having to install different dependencies on our host. And then we can get rid of the containers when we don't need them. So with this, I wrap up this section, and I hope to see you in the beginning of the next section.